Imagine a world with rings so vast they dwarf Saturn's by 200 times. A cosmic giant lurking 434 light-years away, cloaked in mystery. This is J1407B, often dubbed Super-Saturn, a celestial enigma that stunned astronomers when its colossal ring system blotted out 95% of the star's light in 2007. Discovered in the constellation Centaurus, it's not just a planet. It's a spectacle, a puzzle that challenges everything we thought we knew about planetary systems. Is it a planet, a brown dwarf, or something else entirely? And what do those rings tell us about the birth of moons, or even worlds? In this documentary, we'll unravel the secrets of J1407B, from its jaw-dropping discovery to the latest theories shaking up astronomy. Why does it matter? Because this isn't just about one object. It's about how planets form, how moons emerge, and what mysteries still hide in the vastness of space. Get ready to explore a ring titan that's rewriting the cosmic rulebook, one eclipse at a time. The story of J1407B begins not in the distant reaches of space, but here on Earth, with a network of robotic eyes scanning the heavens. In 2007, the Super Wide-Angle Search for Planets, SuperWASP, caught something extraordinary. Over 56 days from April to June, the star V1400 Centauri, a young sun-like star 434 light-years away in Centaurus, dimmed in a bizarre, symmetrical pattern. This wasn't a typical flicker, it was a cosmic blackout, with light dropping by up to 95%. What could cause such a dramatic eclipse? Enter Eric Mamajek, an astronomer at the University of Rochester. In 2010, his graduate student Mark Picot sifted through SuperWASP data and pinpointed the culprit, a massive object with an enormous ring system. Their 2012 paper announced J1407B to the world, suggesting it orbited V1400 Centauri as an exoplanet or brown dwarf. It was like finding Saturn on steroids, Mamajek said, marveling at rings spanning 90 million kilometers, 56 million miles, far outstripping Saturn's 282,000 kilometer reach. This wasn't a fluke. It built on years of exoplanet breakthroughs. The 1990s brought us hot Jupiters via radial velocity, then transits revealed countless worlds. But J1407B was different. A transit so extreme it hinted at a ring system unlike any seen before. By 2014, Matthew Kenworthy and Tim Van Werkhoven refined the model, revealing gaps in the rings, possible signs of moons forming. Yet, one question lingered. If it orbits V1400 Centauri, why hasn't it eclipsed again? The discovery electrified astronomy, promising a glimpse into planetary evolution. But as data grew, so did doubts. Was J1407B bound to its star, or a rogue wanderer caught in a once-in-a-lifetime pass? The stage was set for a cosmic mystery that's still unfolding. So, what do we really know about J1407B? Let's break it down. First spotted in 2007, this object, whether planet or brown dwarf, boasts a ring system stretching 90 million kilometers across, with over 30 distinct rings. During its 56-day eclipse of V1400 Centauri, it blocked up to 95% of the star's light, a feat Saturn's rings could never match. Its sheer scale is mind-boggling, 200 times larger than Saturn's, with enough material to equal an Earth's worth of dust and rock. But what's it made of, and how did it get this way? The rings aren't uniform, they're pocked with gaps. One, at 61 million kilometers out, spans 4 million kilometers wide, likely carved by an exomoon less than 0.8 Earth masses. Think a shepherd moon like those in Saturn's rings. Another gap, 1 million kilometers wide at 53 million kilometers, hints at a smaller one. These gaps are smoking guns, says Matthew Kenworthy. They suggest moons forming right now, accreting from the disk. Models estimate J1407B's mass to 10 to 40 Jupiter masses, teetering between planet and brown dwarf territory. But here's the catch. Its orbit, or lack thereof, complicates everything. Initially, J1407B was thought to orbit V1400 Centauri every few decades on an eccentric elliptical path. Yet, no repeat eclipses have occurred since 2007. Why? In 2019, Kenworthy's team used a very large telescope and found no massive companions beyond $30 Australian, ruling out anything over 6 Jupiter masses nearby. It's likely free-floating, Kenworthy suggests, a rogue object that just passed by. Its rings, then, might predate the eclipse, stable for millennia. The ring's motion adds intrigue. A 2024 study by Wenshui Liu from Hunan Normal University posits they spin retrograde, opposite J1407B's orbit, making them more stable against stellar tides. If prograde, they'd collapse in a few orbits, Liu notes. This could mean J1407B was ejected from its birth system, its rings a relic of a chaotic past. Alma's 2017 sighting of a faint object near V1400 Centauri, less than 6 Jupiter masses, might be J1407B, but its motion remains unconfirmed. What about its star? V1400 Centauri, a 16-million-year-old sun-like star, shows a 5.4-year magnetic cycle, but no signs of orbiting giants. If J1407B's a rogue, the 2007 eclipse was a cosmic fluke, a 1 in a billion alignment. Statistics support this. In young star clusters like Scorpius Centaurus, rogue planets aren't rare. It's a snapshot of a violent universe, says Eric Mamajek, where collisions and ejections shape worlds. The climax? J1407B's rings aren't just a spectacle, they're a laboratory. They mirror the early solar system, when moons coalesce from disks around Jupiter and Saturn. Could J1407B be a brown dwarf birthing a mini-planetary system, or a planet caught mid-escape? Every clue pulls us deeper into the cosmic unknown. It's 2025, and J1407B remains a tantalizing enigma. Once pegged as an orbiting exoplanet, it's now widely seen as a free-floating object, a rogue planet or brown dwarf with rings that defy imagination. Alma's 2017 glimpse of a faint, dusty object near V1400 Centauri matches J1407B's profile, but a single sighting isn't enough. We need its motion, says Kenworthy. Is it drifting away, or just a background trick? Follow-up ALMA data from 2024, still under review, could settle it. The rings are the star here. Spanning 90 million kilometers, they're a dynamic system, gaps widening as moons form, dust thinning as it disperses. JWST's infrared scans in 2023 found no thermal glow from a massive planet, capping J1407B below 6 Jupiter masses. It's a sub-brown dwarf, suggests Mamajek, a planetary mass object caught at the right moment. The challenge? Confirming its trajectory amid V1400 Centauri's glare. Today, J1407B fuels a trend. Rogue planets aren't outliers. With over 5,000 exoplanets known, free floaters like it hint at a galaxy teeming with wanderers. Amateur astronomers, via groups like AVSO, monitor V1400 Centauri for new eclipses. None yet. The question persists. Was 2007 a one-off, or are we missing the bigger picture? What lies ahead for J1407B? If it's rogue, its rings could last millions of years, slowly birthing moons before fading into space. By 2050, telescopes like the Square Kilometer Array might track its drift, pinning down its mass, perhaps 10 to 20 Jupiter masses. If we catch another eclipse, Kenworthy predicts we'll nail its orbit, or lack thereof. Long-term, J1407B's fate hinges on its nature. As a brown dwarf, its rings might spawn a satellite system. As a planet, they'll disperse. Liu's retrograde model suggests stability for now, but cosmic collisions could reshape it. It's a time capsule, Mamajek says. In a billion years, it might be a moon-rich rogue. Could it drift toward another star, sparking new mysteries? The bigger picture? J1407B refines our hunt for ringed worlds and rogue planets. Keys to understanding cosmic chaos. Its next eclipse, if it happens, could rewrite the story. Are we on the verge of a breakthrough, or destined to chase a ghost? J1407B is a cosmic marvel, a ringed titan that dazzled us in 2007, then slipped into shadow. We've learned it's likely a rogue. Its 90 million kilometer rings a fleeting glimpse of moon formation. Its mass a whisper below 6 Jupiters. From Super-Saturn's discovery to Alma's hints, it's a tale of wonder and revision. What lingers? That a single eclipse unveiled a universe of possibilities. Rogue planets, forming moons, and disks defying the odds. It's a call to keep looking, to question what we see. So, next time you spot Centaurus in the sky, think of J1407B and wonder what else roams the dark, waiting to be found.